Now we are in a space where we can prove or we can try to understand why this algorithm, which is called as ASR, is actually going to work better. Okay, so nobody wants me to give you this algorithm steps again, right? It's understandable, fine. So we are now going to have one definition, small one, which is called as an admissibility of the heuristic or admissible heuristic. Okay, please understand there is no common heuristic for a particular problem. I may have for same problem different heuristic. For the Romanian traversal, अगर distance ही मेरा judgment criteria है, तो straight line distance or straight length distance is one of the heuristic that I can use. But besides the distance, I may be also having other heuristics, like I know that some of the paths are shorter, but they are more crowded. So I may have such features about the paths as well while taking into account or forming a heuristic. Okay, so please understand that we are currently considering for our problem very general and very ideal scenario where the distance is a measure of how early you can reach to a next destination. But that's not the always a case that you and me also know, because if so I live in Kalyan, so if the Patripul was, when the Patripul was not rejuvenated or it was not revamped, going to Kalyan east from that region, from that particular old bridge, would cost me a very much dear than going through the Subhash Chowk route, which is a longer route to go to Kalyan east from Kalyan west. But maybe that longer route could take you early because the other route was heavily crowded. Okay, so that's a thing for you. Now, this particular definition, admissibility of heuristics, come into picture because of the reason that there are multiple heuristics possible, and we want to find out a heuristic which is better than the other heuristic, or which will give us a better result. And that's why these properties of heuristics we are going to learn. Two properties are there. One is this admissibility, and the other one is consistency. The other property is consistency. Okay, so both the properties we'll learn one by one. First, the definition of admissible heuristic. A heuristic h of n is admissible if for every node n, h of n is less than equal to h star n. Now, what is h star n? H star n is the true cost. So what does true cost means? Say I am at node n. Okay, I've already incurred cost reaching node n as g of n. Okay, and when I reach the goal node, say suppose with some path, particular path, when I reach the goal node, my g of I should say capital G of capital G will be the cost that I incur to reach the goal node. Now, if I subtract from g of n, the value that I get is going to be the path cost for this path. It is going to be path cost for this path. Now, if I am writing h of n here, what it means? It means it's a heuristic cost of reaching goal node with the cheapest path. And now when I actually follow the cheapest path, the cost that I incur is g of capital G minus g of n. Now this quantity को थोड़ा easily represent करने के लिए what they've chosen is they've chosen this notation to write as h star of n. So this h star of n is the actual cost. Although they're using h here, but they are defining another function. Star लिखा है because they want to have a notation to define another function. ये mathematics में बहुत बार होता है. Same notation, you alter it a bit and you say that now this function is this one. Okay, but what actually h star n is? H star n is g capital G minus g of n. G of capital G minus g of n. That is the actual cost you incurred for reaching from a node n to the goal node using a cheapest path. Okay, this will be understood after you follow the path. Until you reach the goal node, ये आपको पता नहीं रहेगा. लेकिन एक बार प्रॉब्लम सॉल्व करने के बाद you can do this analysis and understand whether h of n is always less than equal to h star n for all n's. If so, you will now learn a new understanding about h of n, and that understanding is h of n is admissible. मैं ये h of n यूज कर सकता हूँ मेरे प्रॉब्लम के नेक्स्ट इटरेशन के लिए. नया प्रॉब्लम इसी तरीके का आएगा. टू सॉल्व दैट प्रॉब्लम I can easily use h of n. This is what admissibilities tell you. And admissible heuristic का मतलब होता है ऐसा heuristic जो कभी भी ओवर एस्टिमेट नहीं करता. It always underestimates. See this particular less than equal to sign. It always is having a less value, less estimated value than what you will actually incur. यानी आप actually जो incur करोगे उससे वो कम कॉस्ट प्रेडिक्ट करेगा. तो कम कॉस्ट प्रेडिक्ट करेगा मतलब वो थोड़ा कंजर्वेटिव है. दैट इज व्हाट यू कैन से अबाउट दिस पर्टिकुलर ह्यूरिस्टिक. एन एडमिसिबल ह्यूरिस्टिक इज कंजर्वेटिव वन. इट इज एन ऑप्टिमिस्टिक वन. वो ऑप्टिमिस्टिक है. वो उसको एक्चुअल कॉस्ट से कम उसका गेस रहेगा. उसका गेस जो है वो एक्चुअल कॉस्ट जो इनकर होगा उससे हमेशा कम रहेगा. ओके, दैट्स अ गुड क्वालिटी. Why that is a good quality, we'll come to the discussion when we mix these two things together, admissibility and the not completeness, that word is not coming to my mind. Consistency. Yeah, consistency. Now what is consistency? A heuristic is consistent rather if for every node n, every successor n dash of an n generated by any action a, दिस पर्टिकुलर कंडीशन होल्ड्स. ये कंडीशन क्या है? ये कंडीशन को बोला जाता है ट्रायंगल इनइक्वालिटी. सो मेरा ये नोड n है. दिस इज n डैश. दिस इज द h of n that I estimated. So this is the cost h of n to reach the estimated cost to reach the goal node using cheapest path. Okay, n dash can be any of my successor nodes. If I am node n, then the cost to go from n to n dash through action A, okay, some action A, this is the C, okay, cost C है, ठीक है. And this cost plus the h n dash, the estimate to go reach goal node from n dash using the now cheapest path, okay, that is h n dash. So h n dash और C n n dash इन दोनों का एडिशन जो है, यानी ये जो कॉस्ट होगा ये हमेशा अगर ज्यादा है इस कॉस्ट से, then I say that my heuristic is consistent. So what it means? It means that as I go closer to the goal node, okay, I am getting better at my estimations. I am getting better at my estimations, right? Because this hn and this hn dash, इनमें अगर कुछ relation है तो वो ये additional cost का है, right? This is a cost that is incurred. So this is some positive integer. So it is increasing. It is increasing order. So that is what it says. Okay. F of n is non-decreasing along non-decreasing यानी increasing order का function है. F of n is a non-decreasing function. Okay. First node selected for the expansion must be an optimal solution, since all the later nodes will be at least as expensive as this node, and this is why hn is if hn is consistent, and this theorem is very important. If hn is consistent, hn अगर consistent है तो a star algorithm जो graph search algorithm पे based आपने किया है is going to be an optimal. That is why we need to understand the concept of consistency. Consistency में internally admissibility included. If the heuristic is admissible, it can also be consistent. I can check for consistency then. And if the consistency is followed and I am using the graph search, then that heuristic is going to give me an A star algorithm which gives me an optimal solution. Okay, so ultimately हम लोग ये सब क्यों algorithm सीख रहे थे? Because the first algorithm that we studied, this algorithm, greedy best first search algorithm, was not optimal and it was also not complete. So at least now we know that the graph search based algorithm of A star, if H, the heuristic function, is consistent, okay, then if I'm doing graph search based implementation of A star algorithm, I am going to get an optimal solution. Okay, optimality proof I'm not going to discuss because I don't think people are going to ask you this. You read it once, you will naturally understand it. It's a straightforward proof. It's not difficult to understand. Okay, but read it once. ऐसा ना हो कि कोई actually पूछ ले, पूछते नहीं कोई भी, लेकिन तभी भी. This is the algorithm for A star. Initial state on the start, so you are putting that into the start. If start is empty or start is equal to goal node, you are terminating. Okay, remove the first node from the start as A. If A is equal to goal node, terminate with success. If A is a goal node, terminate with the success. Else, if A has a successors, generate all of them. Estimate the fitness number for successors by totaling evaluation function value and cost function value. Sort this list by fitness number. Fitness number means the f of n, evaluation value. Okay, उसको fitness function भी बोला जाता है. Replace start with the new list. Replace the start with the new list, and you keep on doing this step again and again, and that is how the A star algorithm works. We have already seen it, how it works. These are the formal steps. Now these are properties of A star. It is complete unless there are infinitely many nodes. If the nodes themselves are infinitely many, that is the state space itself is infinity, then it may not be complete. I may not get the solution. But if the number of nodes in the state space is finite, I'm going to get a solution if it exists. That is, the A star algorithm is complete. The time for A star algorithm is exponential. The space complexity, it keeps all the nodes in the memory, so it is not good with respect to space complexity, as was the breadth first search algorithm. But is it optimal? Yes, it is optimal, and the reason, the cases for which it is optimal is, it is going to be optimal if H, the heuristic that we have chosen, is consistent. Okay, and I'm following graph search variant of the implementation. ये दो requirement है. It's not just yes. Okay. The problems here are obviously there. One problem is of time complexity, and the other problem is of the space complexity. They are of essence to the A star algorithm, and usually A star runs out of the space long before it runs out of the time. So for the problems with large state space, should I go for A star algorithm? I may go for A star algorithm if I want to have a complete and optimal algorithm, but I need to keep in mind how much memory I do have. If I'm a robot who has a, say, 256 KB of memory or 256 MB of memory, I should not say KB nowadays, MB of a memory, small memory size, constrained memory is there, primary memory is there. I can't have my larger list in my memory. I can't have a larger list in my memory for my A star algorithm to work. Okay, so that kind of analysis you need to do as a programmer to select whether to use A star or not. Now, to utilization of positives of A star and still uh, allow you to work with A star with constrained memory, you will have an alternative of A star algorithm, which is called as memory bounded heuristic search. Okay, memory bounded heuristic search. There are 4 types of them. One is iterative deepening A star. These are all variants of A star. Okay, recursive best first search algorithm. This is not variant of A star. This is recursive best first search. So this is greedy search algorithm ka recursive variant hai. It's a recursive implementation, so it replaces that maintenance of queue and avoids a lot of nodes in the memory. Then we have memory bounded A star and simplified MA star. Okay, simplified memory A star, that is MA star. So these algorithms are variant of A stars. Again, I'm not going to cover these algorithms because they are beyond your syllabus level. Okay, that is what I feel. But you should go through these slides once and just get through a feel what exactly they do and how they calculate the things. If you have any doubts after reading the slides, I will definitely explain them once if you ask me to explain them. Okay, otherwise I'm going to skip. It will be teaching a star as well. I'm skipping a star, RBFS as well. I'm not going to discuss these algorithms. What's the next? Okay. This is how you judge admissibility of heuristics. This topic, do we have time? No. I will actually continue with this topic next lecture. You can put your roll numbers along with your names in the chat window. We'll meet tomorrow and we'll start off with this topic, the admissibility of the heuristics. I will be sending these slides of informed search. Do read them. Do go through these variants of A star algorithm. What you should remember with respect to the examination point of view is that A star has definitely some issues, and those issues are mainly related to time and space complexity, more so with respect to the space complexity. Okay, remember this slide. Okay, if you read it, you will understand. Use A star problems, then you will have these four alternative algorithms, and those algorithm names are here. You read a brief about them, you remember a wording or two about them, and that's enough for your syllabus. Okay, so we'll stop here. You put your roll numbers, and if you have already done, no issues, you can leave the session. I hope you're taking advantage of I'm recording the session and keeping them on the YouTube. If you